दृष्टुं ज्वलन्तं सर्वतोमुखं नृसिंहं भीषणं भद्रं मृत्युं नमाम्यहम्. Dear students, last class we have discussed the properties of alcohol and how to distinguish the three types of alcohol: primary alcohol, secondary alcohol, tertiary alcohol, by two sensitive tests called Lucas test and Richter's mass test, because that is a question for the 12th class students in exam. Suggest a test by which how the three types of alcohols can be distinguished. You can write Lucas test or can write Richter mass test, or there may be MCQ question from the what is Lucas reagent, or what is silonitrile, or what is nitrolic acid. Such questions may come. Now this class we will be discussing about conversion of methyl alcohol to ethyl alcohol, and conversion of primary alcohol to secondary alcohol to tertiary alcohol. This may be a question: conversion of primary methyl alcohol to ethyl alcohol and methyl alcohol to methyl alcohol. That may be a question of 3 marks for a student of 12th class. Now let's come first conversion of first we will discuss methyl alcohol to ethyl alcohol, CH3OH to C2H5OH, ethyl alcohol, and the vice versa, the ethyl alcohol to methyl alcohol. This is ascending the series and descending the series. Here the series is ascended. Here in methyl alcohol we have 1 carbon atom, and we want to convert ethyl alcohol. There are 2 carbon atoms. There you have ethyl alcohol 2 carbon atoms, and you will get into methyl alcohol. This may be a question for 2 mark question or 3 mark question. Generally comes for the students of the 12th class. Or you may have a question in an entrance exam: an organic compound A treated with so and so form, B treated with so and so form, C treated so and so form, D. If D has the molecular formula this, then A, B, C, D are. A, B, C, D, 4 type of alternatives will be there. So now let's come to methyl alcohol to ethyl alcohol. CH3OH we are converting to ethyl alcohol CH3CH2OH. Now wherever there is an increase of carbon atom, we go by Ur synthesis. We have read in alkane, when an alkyl halide treated with pure and dry sodium in presence of dry ether, 2 molecules of alkyl halide undergo intermolecular condensation to form a alkane containing twice the number of carbon atom of the alkane. So if you take alcohol, methyl alcohol, and then convert it to methyl bromide or methyl iodide, then we will do the Ur synthesis. We will get ethane. From ethane we will get ethyl iodide. Then hydrolysis we can get into the ethyl alcohol. So upgradation always done by 2 methods: one by Ur synthesis and second by cyanogen synthesis. If once you are very clear about the fundamental concept, wherever there is increase of carbon atom, we go by Ur synthesis and or second by cyanogen synthesis. Now when you come to this methyl alcohol is taken, we will treat this with hydrogen iodide plus zinc chloride. So this will form methyl iodide. Then this methyl iodide now treated with sodium plus dry ether heated to 150 degree centigrade. It will undergo Ur synthesis. It will undergo Ur synthesis. You have done an alkane, CH3I plus CH3I, sodium 2NaI will go and you will get ethane. We get ethane. So now we got an alkane with 2 carbon atoms, we got ethane. Now from ethane, what's our job? We'll remove a hydrogen atom and put OH. We cannot remove a hydrogen atom, put OH directly. So always the OH is given through a halogen. So when you take now CH3, this upon treatment with again chlorine, in 1 mole of chlorine in presence of ultraviolet rays, this forms CH3, CH2, Cl undergoes substitution reaction. We got ethyl chloride, and this ethyl chloride, when treated with moist silver oxide, this forms as ethyl alcohol. This we got as ethyl alcohol. So always whenever this question comes to us, increase of carbon atom, the given compound is converted to its alkyl iodide or alkyl bromide or alkyl chloride. Then we do by sodium dry ether, we heat to 150 degree centigrade. 2 molecules of this will react to form, undergo Ur synthesis to form ethane. And ethane 1 mole of chlorine. Why 1 mole I am writing here? Now because it will take a chain reaction. It is a chain reaction. So one only we want to remove 1 hydrogen atom. So 1 mole we take ethyl chloride, then moist silver oxide. We can use here aqueous KOH, aqueous sodium, but there is a risk. I have discussed with you while discussing the preparation of alcohol that there is a chance for formation of alkene undergoing elimination reaction. So it is always better to take moist silver oxide to get this. So here you can write as a hydrolysis. This reaction is called as hydrolysis. So this is ethyl alcohol. We can do this by the cyanogen synthesis. That means instead of getting an alkane, we will convert into a cyanide, alkyl cyanide. Then alkyl cyanide will be reduced to form amine. Amine on hydrolysis gives us alcohol. So we can go by the, or this can be done by the cyanogen synthesis. We take methane, methyl alcohol, CH3OH, and this methyl alcohol is treated with hydrogen iodide in presence of anhydrous zinc chloride, and we get methyl iodide. We got the methyl iodide. Then this methyl iodide is treated with potassium cyanide in presence of alcohol. We take a medium alcohol. This reaction takes place in alcoholic medium. So potassium and iodine, they will go as a potassium iodide. So they'll form methyl cyanide, CN. So this is called methyl cyanide, or this is another, its another name is also acetonitrile. This another name of this compound is acetonitrile, and this acetonitrile is now reduced. This is reduced by lithium aluminium hydride. Lithium aluminium hydride. Then what are this? Cyanide. This is a pi bond and this is a pi bond. There are 2 pi bonds. There are 2 pi bonds. These are the 3 bonds. Cyanide group has 2 pi bonds and 1 sigma bond. So this bond will break. We'll add a hydrogen. Now this bond will break. We'll add a hydrogen and hydrogen. So we got the molecule here as CH3, CH2, NH2. This is ethylamine. This is ethylamine. So this ethylamine is treated with nitrous acid. How we get the nitrous acid? This we get nitrous acid as sodium nitrite plus HCl. So always nitrous acid is produced in the reaction medium. So OHNO, this is nitrous acid. So H 2 will go with O as H2O, N will go with as N2, we will get CH3, CH2OH. So we get here CH3, CH2OH. So this is ethyl alcohol. So wherever you are introducing one carbon atom, if there is an increase of one carbon atom, the best method is we can go by Ur synthesis or we can go by cyanogen synthesis. I will teach you what is cyanogen synthesis after finishing this alcohol chapter. So there what by cyanogen synthesis is 5 in 1. The cyanide group, the cyanogen group can give us alcohol, amine, carboxylic acids, aldehydes. So many compounds can be possible by introduction of cyanogen group. We will do that separately, cyanogen synthesis. So this is the two methods we done by methyl alcohol can be converted to ethyl alcohol, or you can go by same method, ethyl alcohol to propyl alcohol to butyl alcohol. By this way we can go. Now we will come to the reverse, the ethyl alcohol to methyl alcohol. Here we are going to now ethyl alcohol. We are degradation of this. So such where the removal of carbon atom is always proceed with decarboxylation. Wherever the carbon atom is to be removed, the best way the carbon atom is removed by decarboxylation. That means the given compound is converted to its carboxylic acid. So we will convert the CS2 group to carboxylic acid group. CS2OH group will convert to carboxylic acid group. How we will convert? We know that a primary alcohol when treated with alkaline KMnO4 undergoes oxidation to form an aldehyde. The aldehyde on prolonged oxidation gets oxidized to form a carboxylic acid. We will get the COH. Then we will remove that COH. We have read in alkane chapter. When an acid salt, sodium salt of a carboxylic acid is heated with soda lime, undergoes decarboxylation to produce a lower alkane. This we have read in alkane chapter. So we will take the ethyl alcohol, then convert that to acetaldehyde, then convert that to carboxylic acetic acid, then sodium hydroxide will get sodium acetate, heat with soda lime will get methane, then chlorine, methyl chloride, then hydrolysis we get methyl alcohol. So this is the way we get CS3, CS2, OH, ethyl alcohol. We will take the ethyl alcohol, is a primary alcohol. So we take this and treat this with alkaline KMnO4. This undergoes oxidation. So this primary alcohol gets oxidized to aldehyde. So we'll get CS3, COH. This is acetaldehyde. We get this acetaldehyde. This acetaldehyde now we can oxidize this again, it will be oxidized. So we'll take alkaline KMnO4. This again will undergo oxidation to form acetic acid, CH3COOH. This we have done in the property of alcohol, we get acetic acid. Now this acetic acid, when treated with sodium hydroxide forms its salt CH3COONA, Na plus O minus. This is called sodium acetate. Now when this is treated with soda lime, this is soda lime is a mixture of sodium hydroxide, calcium oxide. This is called soda lime, and it is heated. So what it does, this sodium hydroxide, calcium oxide helps here as a catalyst. It helps, plays a role of a catalyst. removal of the carbon dioxide. Removal of the accelerate at a lower decreases the decomposition temperature. The calcium oxide is called as quicklime. It has a property of observing carbon dioxide. Observing carbon dioxide. So and another property it has that it decreases the decomposition temperature. At a lower temperature, the decomposition can be possible. That's the reason calcium oxide. Then who takes part in the reaction? Sodium hydroxide. This sodium hydroxide, this you will get like this. This NaO, COONA, they go as sodium carbonate. What they go? The sodium carbonate is removed. So we get here methane. So this we have done while studying preparation of alkane, decarboxylation of sodium salt of carboxylic acid. Now chlorine 1 mole, ultraviolet ray, we get methyl chloride. We get methyl chloride. This methyl chloride upon treatment with moist, or you can take aqueous potassium hydroxide, undergoes hydrolysis to form methyl alcohol. You see, this is nothing. A student, I am appealing you children, you don't try to remember these things. So this you have done. Preparation of property of alcohol. Alcohol undergoes oxidation to form aldehyde. Aldehyde undergoes oxidation to form a carboxylic acid. And always remember, whenever you want to remove a carbon atom, the carbon atom is best way removed by elimination of carbon dioxide. That process is called decarboxylation. And decarboxylation is best done by taking the sodium salt of the carboxylic acid and heating with soda lime, we get the alkane. And this alkane, chlorine with 1 mole methyl chloride, undergoes 3 radical substitution reaction to produce the methyl chloride. Then aqueous KOH, this undergoes hydrolysis to form methyl alcohol. This is a question for 2 mark or 3 mark question. Generally a student of 12th class they get in the question paper. Conversion of ethyl alcohol to methyl alcohol. Now we'll go to next, that is a conversion of a primary alcohol to secondary alcohol and secondary alcohol to tertiary alcohol. Conversion of primary alcohol to secondary alcohol and secondary alcohol to tertiary alcohol. Now let's come. Primary alcohol, that is, we'll have a ethyl alcohol to isopropyl alcohol, then isopropyl alcohol to tertiary butyl alcohol. Well, the conversion of so these are the questions I am discussing, because these questions are obvious questions for a board exam. Primary alcohol, primary alcohol to secondary alcohol, then secondary alcohol to tertiary alcohol. This is also a question. Conversion of ethyl alcohol to tertiary butyl alcohol or ethyl alcohol to isopropyl alcohol, a question may come to you. Now let's come. We'll take one, that is ethyl alcohol, CS3, CS2, OH. This is ethyl alcohol. We will convert, this is a primary alcohol, we are converting to a secondary alcohol, CS3, CH, OH. This is isopropyl alcohol, a secondary alcohol. Isopropyl alcohol as secondary alcohol. Now, whenever a question comes to you, children, never remember this question. Apply your mind. Compare this. What is the comparison? You have 2 carbon atom, here you have 3 carbon atom. So, this alkyl group we have to include from ethyl alcohol. We are removing, when you compare this with this and this, when you compare, what is this? A methyl group is introduced. Now, how? What is a methyl group? CS3 group. is a alkyl group. Alkyl group. I have told you one sentence. The Grignard reagent is a precursor of carbanion. Is a precursor of carbanion. That is R minus. Grignard reagent always subscribe A R minus. So this carbon atom of alcohol has a positive charge. So you can add CH3 there by help of Grignard reagent. So this is by Grignard reagent synthesis. Then how to do? What is this comparison now? This, if you compare this isopropyl alcohol, you want to prepare isopropyl alcohol. You see, I have been telling you most often the question gives us the answer. If we ask the question once, twice, thrice, if you ask the question will give you answer. Now what? This alkyl group, methyl group, we can go by Grignard reagent synthesis. Precursor of carbanion, Grignard reagent synthesis. And hydrogen we can get from hydrolysis. We can get this by hydrolysis. So who remain here? CH3, CHO. Bas, he told you the answer. What he tells? Bhaiya, you take ethyl alcohol, convert your ethyl alcohol to acetaldehyde, then treat it with a Grignard reagent, then hydrolyze this, I will give you propyl alcohol. Where is the question of remembering it? Where is the question of by hearting it? And where is the question of practicing? No, not at all necessary. Once you decide fundamental, if you are making yourself rich, if you clues, I have told you Grignard reagent synthesis is done always for alkylation. So what is happening here? Alkyl group is introduced. So alkyl group can be obtained from Grignard reagent. Then how to do that? That means the given compound, he says this is obtained from Grignard reagent, this we will get from hydrolysis. Then who remains here? CH3CHO. What is CH3CHO? Acetaldehyde. Then the question tells us that you take ethyl alcohol, convert it to acetaldehyde, then take acetaldehyde, treat it with a Grignard reagent, then hydrolyze, you will get isopropyl alcohol. So the question itself gave you the answer. Now let's take ethyl alcohol. We start here. We will take the ethyl alcohol. We will take the ethyl alcohol and treat this to dilute alkaline KMnO4. Because we want one step oxidation. We want one step oxidation. So we will get oxidation. We will get acetaldehyde, CH3COH. We got the acetaldehyde. This acetaldehyde, now we will treat it with Grignard reagent, CH3MgBr. Now you think, what is this? There is always a drift of electron towards oxygen. Oxygen has delta negative charge, carbon has delta positive charge. Here Grignard reagent has CH3 minus, Mg is plus, and in presence of ether, then what will happen? The CH3 group is minus, will come to carbon, and MgBr will come to oxygen. So who comes to carbon atom? CH3 minus. What is CH3 minus? A negative group. What is a negative group? Nucleophile. What is happening? Addition. So this reaction is nucleophilic addition reaction. This undergoes nucleophilic addition reaction to form CH3 CHO MgBr. We got this. MgBr went to oxygen negative, Mg is positive, it go there, and CH3 is negative, carbon is positive, it comes here. CH3 minus is a negative charge is a nucleophile, and the both are added, hence the reaction is a nucleophilic addition reaction. So this now, if we hydrolyze this in presence of an acid, always hydrolysis is done by an acid. So this undergoes acid hydrolysis. So what will happen? Here the break take place, H and OH. So at oxygen atom, the hydrogen will take, we get here CH3, CHOH, we got isopropyl alcohol. See, there is nothing difficult in this, there is nothing to remember in this. Only thing I have done, I compare this increase of CH3 group, that is alkylation. Alkylation is best done by Grignard reagent, and Grignard reagent addition takes place in presence of carbonyl compound. Now let's come to secondary alcohol to tertiary butyl alcohol. We will now conversion of isopropyl alcohol to tertiary butyl alcohol. That will complete our this chapter of alcohol. With this reaction will complete our preparation and properties of application of alcohol. Now we will come to isopropyl alcohol, secondary alcohol, CH3, CHOH, secondary alcohol, and we are converting this to CH3, tertiary butyl alcohol. This is tertiary butyl alcohol. Why tertiary? So this is a tertiary carbon atom, and 4 carbon atoms are there, butyl OH there, butyl alcohol, tertiary carbon atom. So now we compare, as I told you, compare this. When you compare, what is the increase here? The increase is what? So if you compare this is tertiary butyl alcohol. This is tertiary butyl alcohol. So this we can get from Grignard reagent, alkylation, and H we will get from hydrolysis. H we will get from hydrolysis. So the question gave us the answer. The question only gave us the answer. So then what remains? CH3CO. CH3CO is what? Acetone. So what he says, you take isopropyl alcohol, convert it to acetone, treat it with Grignard reagent, then hydrolyze, you will get tertiary butyl alcohol. The question gave you the answer. So we will take the isopropyl alcohol and we will do this. So now this is isopropyl alcohol, a secondary alcohol, CH3, CHOH. We treat this with now oxidation, alkaline KMnO4. This will undergo oxidation. The secondary alcohol undergoes oxidation to form a ketone. We have read this. So this forms its ketone, acetone, CH3CO. This is acetone, and this is a sigma bond, and this is a pi bond, and this is oxygen atom is delta negative, carbon atom is delta positive. We will treat this with a Grignard reagent, CH3 methyl magnesium bromide. Magnesium is positive, CH3 is negative, and this takes place always in presence of dry ether. Then CH3 will come to carbon, MgBr will go to oxygen, and this reaction is a nucleophilic addition reaction. So we got now a unstable compound CH3, CH3, O, MgBr. This upon hydrolysis, HOH. This is acid hydrolysis. So this here hydrolysis take place, HOH. We get the compound as CH3, CH3OH. This is tertiary butyl alcohol. So the primary alcohol, ethyl alcohol, we converted to isopropyl alcohol. Isopropyl alcohol we converted to tertiary butyl alcohol. So this is an important topic for a student of 12th class You may get this a question for 3 marks or 2 marks, or he will say, suppose you get a question in entrance exam, you may get a question, organic compound A when treated with alkaline KMNO4 formed B, which on treatment with Grignard reagent formed C. C upon hydrolysis formed D. D has molecular formula C4H10O. The A, B, C, R. He will give 4 alternatives, and the answer is this: C4H10O means that it must be a tertiary butyl alcohol. So then you go by this method. This may be a question also in entrance exam. With these children, I complete your alcohol chapter. Then I have discussed everything. Go through. Anywhere you have any question, anything, you put it on the comment box. You can ask us the question. I will be answering to your question. Next class, I will start with the carbonyl compounds, the preparation and properties of aldehydes and ketones, and the structure of aldehyde and ketone, then properties of aldehyde and ketone, which is a very important topic for a student of 12th class. Thank you very much. Next class we will start with carbonyl compounds.